What's up, guys? It is the Immortal Nerd here, coming at you with a brand new video. It's not on my new channel, it's on my original one. Getting a video up on my new one is proving to be quite a task, so I'm giving you guys this little treat here. I thought it was easier since I've been doing this kind of stuff a lot longer. So as you can see from my thumbnail, what I'm going to be talking about is a little bit of vectors. Not going too deep into it, the basic stuff where it only requires, some basic algebra and a little bit of trigonometry. So to get right into the problem, here I have, some guy being trapped into a maze. To find his way out, he walks 10 meters. At the end of the 10 meters, he makes a 90-degree angle, right turn, walks 5 meters, make another 90-degree angle, right turn, and then walks 7 meters. And the question they ask is, what is his displacement from his initial position? Now, the displacement is defined as the distance between your initial position and your final position. My initial position is before I start making my 10-meter walk. My final position is when I'm at the end of my 7-meter walk. So that little, slanted line there that I have. So here's my diagram. I put up my, 90-degree indications, and I put arrows on my vectors to let you know I'm dealing with vectors. And so this is where I start getting into the problem. I start thinking, I have this, this shape here. I see it's a trapezoid. Maybe can I find the perimeter, of it, or find the missing side of it using the perimeter? Like, well, I can't really do that because they don't give me what the perimeter is of this shape. They just tell me what is, this displacement from my initial position. So I can't really use perimeter. So I have to think of something else. So my next thought is to, let's see if I can make it into different shapes. So as you can see here, this is where I put my dashed line here. And I put another indication of a right angle, 90-degree angle, that lets me know that I have a right triangle there. So my two shapes, right triangle and my rectangle, this will prove to be quite helpful into finding out what that slanted line is, or hypotenuse, on my right triangle. So I'll be using, as you well know, the Pythagorean Theorem. But I need to figure out what those, two legs or two sides of that right triangle are first. Well, if you look at the dashed line, that is part of the rectangle. And you can see a rectangle, the two lengths and the two widths are, equal to their respective parts. So if I look at, the dashed line, I see that is the width. And the width is 5 meters. So my dashed line, that's 5 meters. Now my other piece, I see I have that 10 meters there. That covers that total distance there with the rectangle and part of the right triangle. I just want the piece of the right triangle. Well, in order to get that, I see the rectangle, that length is the 7 meters. And from there I can find out what just the measurement of the right triangle part is. Because if the total distance there is 10 meters and the rectangle part is 7 meters, the measurement for my right triangle side would be the 3 meters. So there you have it. I have my 3 meters and my 5 meters from the sides of my right triangle. Now I can use the Pythagorean Theorem to find out what the hypotenuse is, or what I call the x. So here I have x equals the square root of 5 meters squared plus 3 meter squared, or I should say 5 meter quantity squared plus 3 meter quantity squared. Easy calculations. So you'll get x equals the square root of 34 meters squared. You can put that in your calculator. 34 isn't a perfect square, and you get something around 5.83 meters. Significant digits is 3. So that's all what they want for this problem. Find the displacement. My displacement was x. X is equal to 5.83 meters. Now here, even though they don't ask it, you can also figure out what is the direction of the displacement from your initial position. So what I'm going to do is zoom in on my right triangle. I don't need anything else, just the right triangle. So here you go. You see the angle that I got colored in, and got an arrow pointing to it? That's my direction, or that's my solution that I want. And I see that that angle, my reference angle, is opposite of my 5 meters and adjacent of my 3 meters. So I'm going to use a trig function, and that trig function would be tangent. So in order to figure out what the angle is, I'm going to use the tangent inverse or arctangent of 5 meters over 3 meters. And that will give you somewhere around 59 degrees. And that 59 degrees would be from your initial position in the direction of your displacement. Well, there you have it. That's how you solve this type of vector problem. And don't worry, I'll bring you guys some more ones that require a little bit more thinking. So I want you guys to like, share, subscribe. And if you like these kind of videos, like I said, like it, thumbs it up. Let me know in the comments what you think, or what type of other physics or math problems I should do for you guys. And that's it. It has been a pleasure making this video for you. And like I said, until I get some good juice going, my new channel is going to be blank for a while. So I'll be doing this, to keep you guys occupied, give you guys these treats to get your brain working. All right, I'm gonna end it here. It is the Immortal Nerd signing off.